Hello and welcome. Today we're going to learn to use the angle addition postulate and a few other angle-related tools. The first of which is two relationships that angles can have, being adjacent and vertical. Starting with adjacent angles, which are angles that share one but not both sides and a vertex. The reason they can't share both is because if they did, then they would overlap and not be different angles at all. Moving on to vertical angles, which are angles that are opposite each other when two lines intersect, and they also must share a vertex. The important part, however, of vertical angles is that they are always congruent and have the same measure, which we will prove in probably the next video. The next tool we will learn to use is the angle addition postulate, which states if two angles are adjacent, the sum of the angle measures will be equal to the measure of the larger angle they form. So, here the measure of angle ABC will be equal to the sum of the measures of the angles ABO and OBC. As you can see, it works the same way as the segment addition postulate, just for angles. So let's try out a few problems with it. In this problem, we know the measures of two adjacent angles and need to find the measure of the greater angle, which we now know we can do by adding the measures. So let's do that. And because 50 plus 70 is 120, our answer will be 120 degrees. The degrees symbol is much more important than it may seem, and you will likely not even get partial credit if your answer doesn't include it, so please be careful. I know it seems ridiculous because what other unit could it be, but eventually you will learn other ways to measure angles. Just like the segment addition postulate, we can also use the angle addition postulate in reverse to find a part if we know the whole and other part, by subtracting. 125 minus 53 in this case, which is 72, and once again, please don't forget the degrees symbol. Like with segments, there can also be angle problems with many steps, some even using vertical angles, so let's try one to prepare. To start these types of problems, I always like to label any congruent angles or singular measures that we can find. For this problem, we can see that angles JIK and NIM are congruent because they are vertical angles. We have also been given the measures of angles KIL and LIM, so we should write them too. Next, we should notice that we can find the measure of angle JIK with the angle addition postulate by subtracting, because we know the measures of angles JIL and KIL. So, 105 minus 55, which is 50 degrees. Since we know the measure of angle JIK, we also know the measure of angle NIM because they are congruent. So, NIM is also 50 degrees. Now that the angle we are solving for is in sight, we can finish the problem by adding the measures of angles NIM and MIL to find LIN, which gets us 50 plus 85, which is 135 degrees. Hopefully the cycle of checking if you can use your different tools is more clear now, because next we're going to mix in some algebra. Like I said in a previous video, the first part of problems like this with variables is to set up an equation, and that will be much easier to do once we label everything, starting with any congruent angles, which there are two sets of because we have vertical angles here. The angles with one line are congruent to each other, and same with two lines. However, they are not necessarily congruent to angles with different amount of lines. This notation will be used heavily in the future, so you should fully understand it. Even though there is a line cutting through angle TPR, we can still treat it as its own angle to be vertical to another. Next, we should label any expressions for angle measures, which we have several of. Now we can try to write an equation using congruent angles. We may not have expression for TPR, which would make it easier, but we can find an expression for the angle by adding the two expressions for the angles that form it, which gets us 3x plus 12. Which we can now put into an equation where it's equal to 5x plus 4 because the angles are congruent. Once again, we should already know how to solve these types of equations. For a refresher, watch my videos in the first unit of this course. When correctly solved, this equation should yield x equals 4 as its solution. Now, to find the measure of the angle, we can plug in x into the expression for which we found earlier is 3x plus 12. So, plugging in 4 for x, we get 12 plus 12, or 24. So 24 degrees will be our solution. There is still one more tool we have yet to cover that we can use to help find angles, that being angle bisectors, which are just like line segment bisectors, but they bisect or split an angle rather than a line segment into two congruent parts. As previously stated, angle bisectors split an angle into two congruent or equal parts. In this image, we can only be certain that the line bisects the angle because of the congruency marks, which we should always try to make slightly imperfect like here, so that it doesn't seem like all one angle. With another tool under our belt, let's try using it in a problem. In this problem, we have been outright told that line WZ bisects angle UVX. So, we know that angles UVW and WVX are congruent. We can also see that angles UVW and ZVY are vertical and thus congruent. And because of the transitive property of congruence, we can also say that angles ZVY and WVX are congruent. The transitive property of congruence essentially means that if two things are congruent to the same thing, then they are also congruent. Moving on, we know the measure of angle WVX is 70 degrees, so the other angles it is congruent to must also measure 70 degrees. Now, if we look at the angle we are solving for, we can see that we know the measure of an angle that it's a part of, and the other part of said angle, so we can use the angle addition postulate in reverse to find it, which in this case means subtracting 70 from 115, which leaves us with 45 degrees as our answer. Well, that's all for this topic, so let's finish with some comprehension questions to drill it in. Pause to try them out. And here are the answers. Thanks for watching. I hope you enjoyed and learned something. See you soon.